A function assigns the inputs and corresponding outputs shown in the table below. So our input values, we have -2, 8, 10, and 20. Our outputs, we have 3, -2, -3, and -8. Question A says, does the function appear to be linear? Check at least 3 pairs of inputs and their corresponding outputs. So if it's linear, you'd have a constant rate of change. So we have to go through and calculate the rates of change. So I'm going to start by finding my change in x's. To find your change in x's, you're going to subtract. You're going to take the different pairs of inputs, your x values, and subtract. So you're going to take 8 minus -2, 10 minus 8, and 20 minus 10. I'm going to show you the calculations on the screen. So again, I'm calculating my change in x's, my inputs. So the first row is 8 minus -2. If doing this by hand, the double negative becomes a positive, so 8 plus 2 is 10. The next row you have 10 minus 8, you get 2. And then 20 minus 10, you get 10. So now we're going to calculate the change in the outputs, the change in the y's. So again, you're going to take -2 minus 3, -3 minus -2, and then a -8 minus a -3. Here's my calculations. Again, you're subtracting. So change in y's. First row, -2 minus 3, you get -5. Next row, -3 minus a -2. Again, that's similar to doing -3 plus 2, you get -1. And then the last row, -8 minus -3. So -8 plus 3 is -5. You can use a calculator for those changes. So after you subtract to find the changes in y and x, you have to divide. Remember, when you do your rate of change, you do change in y over divided by change in x. So for the first row, you're going to use the following. You have -5, and you're going to divide it by 10. Remember the y on top. So -5 divided by 10 is -0.5. For the next set of values, you have -1, and you're dividing by 2. So -1 divided by 2 is -0.5 again. And then the last set of changes, you have -5 over 10. And you get -0.5 again. So please note here, all of the rates are equal to -0.5. So the rate of change is constant, so we're going to answer the following. This is a linear function because the change of y over the change in x values are all equal to -0.5. Okay, so that's part A. Part B, let's look at part B. It says, can you write a linear equation that describes the function? We can because this is a linear function. So keep in mind, when you write the equation of a linear equation, you're going to use the form y equals mx plus b, where m is your rate of change, your slope of your line, and b is your y-intercept. So the m, the rate of change, we already found to be -0.5. We found that up here. So we know the m value, I'm going to plug in that -0.5 in front of the x. Now we got to figure out what the b value is. So for the b value, you're thinking back to your table. If you had a 0 in this column for the inputs, what would be the output that goes with the 0 input? So what I'm going to do to help us think about this is I'm going to use some positive rows here for the inputs. I'm going to use these two rows. So 8, -2, 10, -3. So I'm going to think of that 8 and 10 first of all. I'm trying to get up to 0. If I'm going from 10 to 2, I'm counting by 2. Sorry, 10 to 8, I'm counting by 2s. So count by 2s. 10, 8, 6, 4, 3, 0. I just counted by 2s there. So now I'm going to look at the y values, the outputs. For 8 and 10, I was given -2 and -3. Well, there, I'm just counting by 1s. So you need to continue to count by 1s until you get up to this x equals 0 up at the top here. So let's do that. Ready? -3, -2, -1, 0, 1, 2. So my b value is 2. So there's my equation, y equals -0.5x plus 2. Part C. It says, what will the graph of the function look like? Explain. Oh, well, this is a linear function. Since it's a linear function, it's going to be, the graph will be a line. So we could say the following. It will be a straight line sloped downwards. And again, this is because it's a linear function. Linear functions are lines. Their graphs will be lines. And that's it. I'm going to stop recording.